Hi, I'm Brady from Portland, Oregon. I'm part of Team Random Eastern/Central 4, and this is the Zoolution.
Hi, I'm Daniel. Okay, let's jump right in. Okay, first we started by looking at the main problems zoos are dealing with today. A lot of facilities are short-staffed and their current systems aren't designed to handle the amount of work needed to give animals consistent high-quality care. This can impact routines, enrichment, cleanliness, and even safety. So our goal throughout this project was to design a system that supports zoo staff and improves the daily experience for the animals. The customers we focused on include zookeepers, animal welfare staff, zoo management, and the veterinarians. These are the people who interact with the animals every day and see firsthand where the challenges are. From our research, we found several big issues. Feeding schedules can be inconsistent, enrichment opportunities can be limited, enclosures are hard to keep clean, and safety concerns like pests or disturbances take a lot of staff time to monitor. Labor demands are also high, and most zoos don't have automated systems to help with these tasks. All right, so here are the four robots we're proposing. First is Munchmine, our feeding and enrichment robot. Second is Wild Whisper, which focuses on sensory stimulation and natural behaviors. Third is our Sanibot, the cleaning and sanitation robot. And fourth is Sentinel, our monitoring and safety robot. Together, these robots cover the major areas of daily care that zoos struggle with to maintain consistently. So Munchmind is our enrichment-based feeding robot. It uses sensors to detect when the animal is near the maze, and once it does, the robot will activate its spinning mechanism, and it'll also use its wheels to move the maze around. This creates a fun chase-style feeding experience that encourages natural foraging behavior while still delivering controlled portions of food.
This is robot number 2, the Wild Whisper. It has a photosensor and a distance sensor, as well as three servo motors for the different scents, and two speakers, a day speaker and a night speaker. When an animal walks by, it will trigger a sound to be played and a scent to be released. The sound is dependent on the light sensor, it's time of day. A robot collaboration we decided to present in this lemur enclosure shows how our robot team comes together to create the solution. Starting off with the Munch Mind, when the lemur walks up to it, the sensor on the side of the Munch Mind is going to realize that there's an animal nearby. It's going to send a high signal to all of the robots around to let it know there's an animal feeding. Munch Mind is going to run away from the animal, creating a chase effect, and is going to cause the maze to start spinning. When the animal is done eating, it will walk away, and the munch mind will realize that there is no longer an animal, send a low signal to all the surrounding robots. As for the wild whisper, when an animal walks by, it's going to notice that with the distance sensor, it's going to release sound as well as scent, causing the animal to explore its enclosure a little bit more, just adding to the environment that the animal lives in. As for the Sandybot, when it is turned on, it's going to search the enclosure for waste. When it finds waste, it's going to scoop that up. And then with its brushes on the back, as it drives past, it's going to clean the area and then continue searching for waste. This is the Sentinel. Sentinel is going to be exploring its habitat for insect infestations. If it finds one, it's going to immediately alert the zoo staff. It's also looking for animals getting harassed. If animals are getting harassed, we'll immediately report to the area, play lights, play sounds, hopefully deter people from messing with the animals, and it's going to alert the zoo staff. Benchmark and value added. Here are three different current solutions on the market. We have a regular feeder. The problem here is it doesn't create any enrichment value for the animals, it just feeds them. In the middle is a spinning one that drops food onto the ground, increasing foraging, but it doesn't have the chase effect that our solution has. And lastly, there's no automated zoo cleaners. This is kind of a Roomba style cleaner. This is not going to be able to handle the zoo. So our SandyBot is going to defeat that in the market.
Okay, so to wrap things up, our robot team improves the four core areas of zoo care: cleaning, feeding, enrichment, and safety. These robots help solve problems that keepers face every day and make the overall workflow more efficient. More importantly, they support better animal welfare by making care more consistent and more engaging. Overall, our system shows how the robots can make zoo operations safer, easier, and more reliable for both staff and animals.